Hello guys, welcome to today's video. Today we're going to be doing a bouncing ball animation with the Java Processing Graphics Framework. So if you have used processing before, I think you will be familiar with what I'm about to do. If you have not used processing before, then just memorize this step right here because it is key to every single processing program. So what you need is that you need a void setup and a void draw class. There we go. And then if you need, well, I need to get some variables. And then this, of course, is a bouncing ball program. So first I'm gonna create a radius for the ball. Second of all, I'm gonna create the X position and the Y position. So what this will do is that it will control where the ball is at all times. Because we can use a frame updating technique to keep making the ball move as the X position changes. So we're also going to do an int X speed 3 because 3 I did a bit of testing before this video. 3 probably is the best to work with. You can change it if you want. You can also change speed with FPS, but I'll show you how later. And then finally, I'm going to create an X direction variable, 1 into Y direction. So the Y direction and X direction variables will help me create the bounce of the ball off the screen, of course. So let's start off with basically what every single processing programmer does. We have a size of the screen. I'll go 800, 600. Pretty simple. So if you're a complete noob to processing, then these two numbers mean the X and Y coordinates. So this will be 800 pixels by 600 pixels long, or I would say the X and Y coordinates. So X, Y chords of screen. Okay. Next, we will go with pretty simple again. We'll have a background color, background 0. That means the background, I'm pretty sure it's black. Yeah, it's black. Yeah, background 0, that's black. Then we'll go with a no stroke. Even though the stroke is black and it doesn't really matter, I still like to go with no stroke because it's just very nice, and you can do it white. You can do a white background later too, but we'll go with no stroke. Okay, and then yeah, I'm pretty sure that's it. Oh, and one last thing I need to do is to center the ball really quick. Close with this is just make sure. Again, this is completely optional. You can leave out this point if you want, but if you do want to, have a nice, almost like perfect optimized look, then you do go like this, because it will center the ball after I do the ball variable. So we'll create a circle. This is a function for circle, and we will have the X position variable, the Y position variable, and the, of course, radius variables. Go. I think I spelled everything right. Okay. I did not spell everything right. There we go. So now we have a circle centered in the middle of the screen. Very nice. Now, our next step is to create the movement. So what we can do here is that we can create, we will update our X and Y coordinates of the circle by using a very basic formula, exposition plus X speed times, and then X direction. And I'll tell you what X direction has to do in this in a moment. Same thing here. I actually can just copy and paste this. Okay, I spelled X position wrong here too. Okay, yeah. Okay. Yeah. I keep spelling the word position wrong, but there we go. And now let's just change this to Y for the Y axis. And we go, and then okay, Y, and then we'll. Okay. So now what this will do is that it will move the ball, yes, but it will first of all create a line, and second of all, it won't bounce. So first of all, to get rid of that line, this is quite easy. We'll just update the background every frame. So background 0. And now the ball is a ball that moves, but it still won't bounce off the corners. So for the corner bounce, what we'll do is that we will have a basic hitbox detection. So what we'll do is that if Exposition becomes, I believe it's larger than, I keep messing up the larger than and smaller than, I may have to change it, but yeah, and then if Exposition is larger than width minus radius, so that you have, the radius will be like the actual ball, and then you have the width minus radius to make it bounce off. Or, this is the or symbol, Exposition radius, I think it's radius. I haven't done processing for a long time, so I may have to change this. Yeah, and then we'll do x direction times equals -1. I may have to just change, check this. So okay, that just went off the bottom. So I will just copy and paste this really quick right here, and then change everything to y, this to height, y. If this, okay, so that does work. I'm gonna check all sides. Okay, so that does bounce. I got it correct on my first try, which is pretty good. So here is your bounce, and that's basically it. Now I will play around with some of the code and tell you what every single part of the code does. So this, I'll go through it line by line and do an analysis of the code. So first of all, you have radius of circle. I think everyone with at least a 5th or 6th grade math will be able to understand this. The radius is basically it is the length from the center of the circle to any point on the side. Exposition, so I think used to control movement, so like where the ball exactly is. So if we run this, the ball is going down, right? So like the every time the ball moves, the x and y of the ball is changing, and that is what controls where the ball goes exactly. Speed of movement, the higher you make these two variables, the faster the ball will go. So let's say we make this 20, 20, and that, as you can see, the ball is moving much faster. Okay. We'll just go with 3 for now because it's a very nice number. And then bounce helps with bounce movement. I will tell you what this means in a second after I just really quickly. So I think like no stroke background, I mean, it's sort of optional. So I'll just do BKG color, and then I guess like no outline, that kind of thing. This is very simple. It's just aesthetics. And this is a bit, less center ball in screen. If we delete this, the code will still work completely fine, but it'll just start up at the corner. I mean, it's not really a big deal, but I'll just go with this for now. You can delete it, okay? If you don't like it, you can delete it. I'm not judging. Next, you have, this is like the main meat of the program here. This will let's see here. Change x, y coords of ball to move x speed, y speed. So exposition, that's basically, we loop this, and then this will be the former exposition, the previous one, plus x speed plus x direction, right? So this will just increase the x and y, meaning that it will move wherever it goes, because you're increasing, right? Increasing means you either increasing on the x means you go right, increasing on the y means you go up. X speed, so that's how fast it increases, and x direction, which is the actual direction of movement. Now here, we use x direction or y direction is -1, the -1 will make this whole thing into a negative number, which will then cancel out this plus sign, make it a minus sign, and that will subtract x, so that's going left, and subtract y, which is going down. This is a very simple movement technique, and this will work for most movements. We can expand this code into a Pong game, two-player ping pong game. So, we can create two variables. Like, we can, first of all, we need to create a points, and then we can draw two rectangles on each side of the screen, make event up key, event down key as the movement for the paddles. And then instead of having the ball bounce off the screen, have it bounce a few, about, I think 70 maybe pixels away from the paddle, so that it actually has the paddle effect, and bounce it. And then if it misses the paddle, it'll go into the screen, and if it disappears off screen, so like if the x and y coordinates of the circle is larger than the x and y coordinates of the screen itself, then it'll stop the game and then award a point to someone. So that can be done. I may do another video on it, but right now this is the bouncing ball program. Moving on, this detects if ball hits side. Right, so each of this, you have four conditions here, separated by an or conditional, and these four conditions will be the four sides. I'm not going to explain exactly like the actual test cases. I think it's pretty simple. You can plug some numbers for yourself, some smaller numbers I suggest, and then just see where the ball will go if you just debug it, and then write down every single step of the way. And then this will create the circle, of course, x position, y position, and radius. And I want to do a quick experiment right now. I'm going to delete the background variable or the background function and let it create a line. And I just want to see where the ball goes after a while of movement. So it does make an irregular pattern, it seems like. I'm not very sure. I want to wait for it to run a bit. It seems that it's creating an irregular pattern. Though it is just tracing its old steps now. So is this like, let's see. So right now it's going back. Okay. Oh, and then it moves, and then, so I'm not seeing any like cohesive pattern here. Probably if I let this run long enough, it may create some pattern, but I'm not seeing any pattern here. Yeah, I mean, it's just kind of like a grid, I guess. Yeah, so that I think will conclude today's video. If you have any questions or anything or any concerns, what I should do next, anything that you want to tell me, comment down below. Please do leave a like and subscribe to this video. I will be doing some more processing videos with Java. I think I've done enough, Python stuff, so I'll go over to processing for a while. But if you enjoyed this video, please subscribe. It helps out a lot, and it really, encourages me to make more videos. So have a good day, guys.